In this video, we are going to take a look at different representations of linear relationships. We're going to see how they can be represented in stories and equations and tables and graphs, and also ordered pairs, which are essentially the same thing as tables. Let's begin. So practice representing linear relationships in multiple ways with the following example. Use the representation you're given to help fill in the others. So here is our story. A baby giraffe measures 6 feet tall when it is born, and it grows an average of 1/2 foot each month. So what is the equation? Well, our important information is when it's born, at the very beginning, it starts off 6 feet tall, and it grows at an average of 1/2 foot each month. Therefore, this right here, 1/2 foot each month, that's like our rate. So that's going to be what's multiplied by our x. That's like our slope. And 6 feet tall is our starting point, which is our y-intercept. So if we were to write that as an equation, we would say, well, y equals mx plus b, right? Where m is the slope, or the rate of change, and b is a y-intercept. So that equation should be y equals our slope, which is 1/2 x, and then our y-intercept is going to be, it's 6, positive 6, because it starts off at 6 feet. So that is our equation. Let's take a look at our table. The process, well, let's just think. What is the height when it's born at 0 months? It starts off at 6, and every month it grows 1/2, so it should go 6.5, or you can say 6.5, and then 7, and at 3 months it'd be 7.5, and then 8, 8.5, 9. Now the process, what process? They are talking about the equation. So if months is x and our height is y, then y equals, if months is 0, it would be 1/2 times 0 plus 6. And of course, 1/2 times 0 is 0 plus 6. Whereas for the next one, it would be y equals 1/2 times 1 plus 6. These are parentheses right there. 1/2 plus 6 is 6.5, which is 6.5. This would be y equals 1/2 times 2, which is 1. 2 times 1/2 is 1, plus 6, so that would be 1 plus 6, which is 7, and so on. If we were to graph this, let's label it. Let's do, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is going to be our months. You can tell because on our table, the first is always the x, and the second piece of info is always our y. So what would this be? This would be our height. So H-E-I-G-H-T, and our height in feet. So when it is born, it starts off at 6 feet. So that is not right here, because this is 1 month right there. When it's born, that's technically 0 months. So right over here. At 1 month, it's 6.5. At 2 months, it's 7. 6.5 is probably right here. 7 is right there. Then 7.5 and 8, 8.5 and 9. And then you can guess where it would go afterward, but draw a straight line through those points. So that's what the graph would look like. Explain how you found ordered pairs to create your graph. Well, I took them from the table. We use the table. We use the table because the first one is 0, 6, which is right there, and then 1, 6.5, which is like right there, and then 3 and 7.5. Sorry, 2 and 7, which is right there. And yes, I didn't exactly do a good job of connecting all the points. The line should touch all the points. Anyways, you use the table. the x, y values in the table. What is the slope of the graph and what does it represent? Well, the slope, if you look at the story or the equation, is 1/2. If you look at a table, you would figure out the slope by looking at the change, which is like, what is the change from one to the next? From 6 to 6.5, you're adding 0.5, right? You're adding another 0.5, and you're adding another 0.5. What's the change in x? Every time you're adding 1, from 0 to 1, 1 to 2, 2 to 3. Therefore, our slope, if you remember, is rise over run, or the change in y over the change in x, also known as rise over run. And the change in the rise, the change in the y is 0.5. The change in the x is 1, and 0.5 divided by 1 is 0.5, also known as 1/2. So 1/2, 0.5, they both mean the same thing. The slope in an equation, of course, is found right here. In the story, it's right over there. In our graph, we can choose 2 points that run through corners, which is there and there. And we check the rise. The rise is +1. The run is +2. So our slope, again, is 1/2, which is the same thing as 0.5. Slope, m equals 1/2. And what does it represent? The representation is, what is the, remember, it's change over y, change over x. So what is the change in y? What is the y value? The y value is height. It is height per, which is like divide by, height per month. So it's the change in height per every month. You can also call it growth. What is the y-intercept of the graph, and what does it represent? Well, the y-intercept on a table in the story is kind of the starting point, which is 6 feet. Y-intercept right here. For the equation is pretty easy. It's not just 6, +6. In a table, it's when the x equals 0, what is the y? It's also 6. And on our graph, it's right there, which is the number 6. So our y-intercept is 6. So I'm going to say b equals 6, because b is the y-intercept. Represents, in our story, height at birth. Height of the giraffe at birth. What does the ordered pair 9, 10.5 represent in the context of this situation? Well, remember, this is the x number and this is a y number. And x refers to the number of months, and y refers to the height, right? So what this means is, at 9 months, let me use it in different colored ink, that might be better. At 9 months, giraffe is 10.5, right there, 10.5. 10.5 feet tall. If the giraffe is 12 feet tall, how many months old is it? Well, how can we figure that out? We can use our table and keep extending our pattern. We can use our graph and try to see where the line is at 12 months, or we could use our equation. And remember, our equation is y equals 1/2 x plus b plus 6. And 12 feet tall, 12 feet, is that the x or is it the y number? 12 feet up, the height, the feet is the y number. So we're going to basically replace the y with, we're going to basically replace the y with 12, because that's the feet. 12 equals 1/2 x plus 6. In order to solve this equation, we can subtract 6 from both sides. So I'm going to draw my wall down the equal sign. 12 minus 6 is 6. 1/2 x, so I can 1/2 times what equals 6? It's 12. I can get rid of this by multiplying by the reciprocal, which is 2 over 1, 2 over 1, and that equals 2 over 1 times 6 is 12. So x would equal 12, which means, if you remember, 12 refers to the months. So if the giraffe is 12 feet tall, how many months old is it? 12 months old. All right, let's do another one. Given the info below, fill in the missing representations. We have our equation, y equals 12 plus 1.5x. It's written kind of weird. Normally, you should do the 1.5x first. And then, because the 12 is positive, you're adding to that. So I personally do not like how this is written. I'm going to rewrite it. 1.5x plus 12. That's much better. Let's see, what's the story about? We can't just make it up. We do have some info, but they give us, looks like it's about pizza because it's pasta pizza and toppings. So the number of toppings and the cost of a large pizza. So it looks like it has something to do with pizza and cost. So let's fill in the information. We know that the y-intercept is right over here. So we can even write on the side, b equals 1.5. The slope is, sorry, b is not 1.5. M is 1.5. And the b, or our y-intercept, is 12. Because remember, slope is always the number being multiplied by x. So when b is 12, that means at the starting point, at the very beginning, the cost of a pizza looks like it would be 12. And after, if the slope or the equation is y equals 1.5 times my number plus 12, that means the next process is going to be y equals 1.5 times 1 plus 12. And 1.5 times 1 is 1.5. Add 12 to that, you should have 13.5. And then let's do another one. 1.5 times 2 plus 12. 1.5 times 2 is 3. That's 3. And 12 to that, you should have 15. So it looks like the pattern is you're adding 1.5. Because it's linear, it's going to be the same each time. So 12, 15.5, or sorry, not 15, add 1.5 is going to be 16.5. Then 18, and then 19.5. And then 21. Process all the way down. Okay, so let's look at the very beginning. Remember, notice the numbers. These go up by 2 as these go up by 1. So just kind of keep that in mind as you're doing the slope. When the x right here is 0, the y is 12. Right there. When the x is 1, the y is 1.5, 13.5. I don't want to graph that. I'd rather graph the next one, 2 and 15. So 2 and 15. And then 4 and 18 is what I'm going to graph next because I do not like those decimal numbers, especially because these are going up by 2. So like 13.5 is actually like 3/4 of the way up. Anyways, I'm going to draw a line cutting through all of these points. All right. So, what is the story? Well, it seems to be that the cost of a pizza with 0 toppings is 12. And then every time you add a topping, 1, 2, 3, 4, 5, you have to add $1.50 each time. And this place is called Joey's Pizza Parlor. So let's say Joey's Pizza Parlor charges $12 plus $1.50 for each topping. That looks like that's it. Or you can say each additional topping. But I think that's all we need for our story. Let's try one more. We've got no verbal description or equation. But we do have a table, and we have some information here. It's about Woodbury Watermelon Patch, and the number of watermelons per weight. So it seems to be that 5 watermelons weigh 6 pounds, and 10 weigh 12 pounds, and 15 watermelons weigh 18 pounds. So what is our rate of change? Let's figure that out. From here to here, we are adding 6. From here to here, we are adding 6 again. 18 to 24 is 6, making sure it is the same thing, 6. And our x values, so this is our x and that's our y. This goes up by 5, right? 5 to 10, plus 5 again, plus 5 again, plus 5 again. So remember, our slope is the change in the y over the change in the x. So the rise over the run, how much is the y rising? It is changing by 6 or plus 6. The run is 5. 6, 5, what? So x, so the y is 6 pounds over 5. It looks like just the number of watermelons. So 6 pounds for every 5 watermelons. Interesting. Let's go ahead and graph. Let's do green, because red and green watermelons. When x is 5, y is 6. So I don't know what the y-intercept is. When x is 5, y is 6. So it's right over there. So it looks like the x goes up by 3 every time, and the y goes up by 5 every time. Next one is, let's do the next one. Next one is 10 and 12. So 10 and 12. Let's do the next one, 15, 18. 15, 18. Then 20, 24. Then 30 and 25. Sorry, 25 and 30. Right there. If I draw a line straight through, I'm going the pattern, going up by 2, over by 1. I should have a point right there, which makes sense. When you have 0 watermelons, you should have a weight of 0. Kind of messed up my line. There we go. What is our equation? Well, we know that the slope is 6 over 5. It's number 6. Our y-intercept is this point right there, and it looks like our y-intercept is 0. And also, if you want to figure out the y-intercept, if you go up 5 each time, if you go backwards 5, you should have the number like 0. So from 0 to add 5, you get 5. And so if I go backwards 1 step, it's almost like I'm subtracting 6, just like over here I'm like subtracting 5 to get to 0, which means the weight would also be 0. So it kind of makes sense. So what does that equation look like? It is proportional, but y equals mx plus b. We know that the m is 6/5, and the slope is 0. But do you really have to write down y equals 6/5 x plus 0? Do you really have to write down plus 0? No, because it's kind of pointless. Here's our equation, y equals 6/5 x. And our verbal description is at Woodbury, I wish this wasn't such a long name, Woodbury Watermelon Patch. Melon Patch. every 5 watermelons weigh 6 pounds. I suppose you can divide that number and figure out that each watermelon weighs, or 1.25, or 1.2 pounds each watermelon. Because 6/5 is the same thing as 1.2. All right, so that's that. Go ahead and try some problems.